Others that we want to talk about. Jack.
Can you do
14. Okay. So you were able to get the length of ME and MF. What did you get for an answer there, Jackie? Well, if you tell me what you got, I'll tell you if it was right or not. You got 87.7-ish. Okay, let me find my answers real quick. So that's correct. 87.75 is the correct answer for part A. So what I would do for this one is, because this is a non-right triangle here, I could use the law of sines or cosines to deal with this one. Since I know all three of the side lengths, it seems like the law of cosines would be the more appropriate one to do. So I'm going to have EF squared is equal to ME squared plus MF squared minus 2 times ME times MF times cosine of angle M. Okay with that idea, Jackie? Okay. So here I have 80 squared is equal to 87.75 squared plus 87.75 squared minus 2 times 87.75 times 87.75 times cosine of M. So M is going to be the cosine inverse of 80 squared minus 87.75 squared minus 87.75 squared divided by negative 2 times 87.75 times 87.75. And if I punch that into my calculator, I should spit out the desired answer. Let's just do that right quick. Dang it. So when I do that, I get about 54.24, and that would be our answer. You could have taken a couple of other tacks on that would have been a little bit more work, but would have involved only using right triangles. But in that sort of a situation where you have a non-right triangle, we can still use law of sines or cosines. And it wasn't too difficult to use law of cosines there, right? But you had to think to do it, which maybe wasn't super obvious. So that's a good question. Who else has some from this? Do we need to talk about some more? Happy to do more if we have any more. Jackie, go ahead. 15, part C. Can you tell me your answers for parts A and B? We may need to end up using them. If they're not right, I'll let you know, and we'll go back and look at those ones.
For A, I got
Excellent. Excellent. My answer key said 0.35, so that's what I'm going to write down. But, like, who cares? It's 100, right? Like, not a big deal to me. Okay. And we want angle MDB. So that's going to be MDB. So we're looking for that guy right there. So I'm going to just draw this off to the side. I can tell here that angle M is a right angle because BM is a segment inside of one of the faces, and MD is a segment inside one of the faces. And all the faces intersect at right angles. Okay with that? Okay. Let's see. And what else can we say here? P is that. I'm just looking for the shortcut here. There's got to be a good shortcut. But maybe there's not. Maybe it... Oh, do we know BM? So what is BM? Okay. So this is 37.08. Fantastic. And MD would not be difficult to find either, right? Because I can just use, I know that this is 15, so I can do the Pythagorean theorem to find that piece then. So this is, MD is 101.12. So then that angle D is going to be the tan inverse of opposite over adjacent. And that gives me about 20.14 degrees, which is what we're supposed to get there. You're welcome. Yeah, I had to look at it for a second to see if there was an easier way than just like filling in the triangle or whatever, but seems like that was pretty easy still, especially since you had MB already. That helped. Cool. Who else? Happy to do some more if we have any more. Benji? 10? Sure. All right. We have a right pyramid on a square base. VO is the vertical height. The length of each side of the square is 26. And the slant height, that is VC, is 38. And we want the value for angle VAC. Okay. First thing that I'm going to recognize is that VAC is not a right triangle. If I just look at VAC, that's not a right triangle, right? So I'm not going to work with that one. instead what I'm going to work with is this pink one we've been hinted at, since I know that that is a right angle there. Okay with that. VA is a slant height there. So VA and VC are certainly the same length. And now what I'm going to do is I'm going to calculate the length for AO. So if I look at the base here, I have this, right? That AO is half of AC. Okay with that?
Yeah, did it say it was a square?
Square base.
Okay, got it.
So AC then is just going to be the square root of 26 squared plus 26 squared. Well, I guess I can just write that as 26 square root 2. So that's going to be 13 square root 2 then here. And I can use cosine inverse. So I got 6107 as my answer. Is that okay?
Yeah.
6107. Could be just your calculator. This one was number 10 that we were talking about. What's up, Nikki? Adam Walker. You got to get out of jail free card here. An hour from now. All right, bridge. 13? Yeah. All right. So right pyramid, the base is a square with side lengths of 10. The slant heights are 18. E and F are midpoints. And we wanted to calculate the first length of VE. Bridge, you said you got that part. What did we get for that? 17.2. This is 13, right? Okay, I had 17.29, but okay, cool. All right, so the next up we have is EF. So what I'm going to do is I'm going to observe that ED and DF are both 5 since E and F are midpoints. So I can just use the Pythagorean theorem for EF. Which gives me 5 root 2, or as a decimal, that would be 707. Cool with that? Okay. And then if we want the size of angle X, what I'm going to do is I'm going to use this triangle VFE. that is drawn in pink, though that triangle is not a right triangle, I do know all of the side lengths since VE and VF are going to be the same, right? So I can use the law of cosines here. So I can say that VF squared is equal to VE squared plus EF squared minus 2 VE times EF times cosine of x. So x is going to equal the cosine inverse of 17.29 squared minus 17.29 squared minus 707 squared over negative 2 times 17.29 times 707. And that should give me the right answer. Let's type that in right quick. So when I do that, I get 78.20, and that should be what we get. Or that matches my answers anyways, which is always a relief, right? Bridge, you happy there? So again, could have done that without having to use the law of cosines, but it can get kind of messy. I think you need 2 or 3 calculation triangles to kind of do it. Law of cosines can knock it out in one shot. So that's what I would do preferably if it's me, but you know. Okay. What do you guys think? Are you happy with the homeworks? Yeah. Overall went all right, I hope? Good. All right. So let's start. Where did I put those? They're over here. Where are they? Where did I put those stupid things? I'll find them eventually, don't worry. There we are. God bless you. You're welcome. There we go. All right. This is the last section in chapter 9. No, not a test tomorrow. We don't even have this class tomorrow, you goofus. All right. So calculating volumes and surface areas is what we're going to talk about today. So some common volume and surface area formulas are, boom. Do you need to memorize these? No. What do you need to know? What the letters are representing, right? So you should be able to know how to use the formulas. So, for example, for a cuboid, stop talking please, a box, the volume is LWH. What does L stand for? W. H. Okay? So the surface area formula contains the same letters. Let's not worry about it. A right pyramid, volume is equal to 1/3 BH. What's capital B? Not quite. area of the base, whatever that shape might be, whether it's a square, a triangle, or a rectangle, or pentagon, or whatever. Okay with that? The surface area is equal to B plus T1 plus T2 plus T3 plus T4, etc. Capital B is the area of the base. What do you think these capital T1, T2, T3, T4 are? Area of the triangular faces to your pyramid. In the case of a square pyramid, you have 4 triangular faces, and they're all the same, right? Everybody's okay with that? So in most cases, all those triangles are going to be the same size, and it's not so bad. But they need not have to be, although I think in this class I would be surprised if you did not have a regular figure as the base of your pyramid. A cone, what is R and H? Radius and height, good. Surface area is pi RL plus pi R squared. What does this script L mean? That's the slant height for the cone, right? That diagonal edge of the cone. Sphere, the only variable is R, which is radius, good. Worth pointing out the surface area, never mind. Hemisphere, what do you suppose the relationship between the sphere and the hemisphere is? It's half, right? So if I take 4/3 and divide by 2, I get 2/3. Notice that the surface area for the hemisphere kind of depends on whether you're counting the bottom or not. So like if you guys have like one of those cupcake domes at your house, right? Like if it's just a cupcake dome and it has no base, the surface area is 2 pi r squared. But if it's like like one of those things in the workout room that has like the half of a ball, that it has a bottom to it, the surface area would be 3 pi r squared. So that's what I mean by no base and without base. Does that make sense? So you have to think a little bit about the context of the question, if it's a story problem. Like, is there a bottom to this thing or not? For a right prism, what was capital B again? Area of the base. Very good. And H is just the height. For a prism, it's noted that the height is that distance between the two bases. So if you have a rectangular prism, really any of the length, width, or height could be count as the height. Like that part doesn't really matter. But if you have like a triangular prism where the two bases are triangles, you have to be looking at the distance between the two triangles. You know what I mean, guys? You'll see some examples in the homework. And then the surface area, you have 2 times area of the base. And what do you think R1, R2, R3, R4 are? They're the rectangular faces, exactly. So if you had a rectangular prism, you'd have the 2 bases on the end, and then you'd have 4 rectangular faces, right? If you had a pentagonal prism, you'd have the 2 bases on the end, then you'd have 5 rectangular faces, etc., etc. And oftentimes those rectangular faces will be the same size, right? If your bases are regular, where they have the same side lengths all the way, then all those rectangular faces are the same. And the last one here, cylinder. Yeah, we know what R and H are, right? Everybody's good there? Okay. And again, the cylinder for the surface area, if we have like just the cone, like those little cone-shaped drinking glasses that have no bottom to it, right? Like a slushy goes in or whatever. That's like having no base. If you have something that's like I don't know. You know what I mean, though. A can of soup. I haven't seen any cone-shaped cans of soup, but we get the idea. Maybe like a candle, like some of the fireworks are kind of cone-shaped. Yeah. Like you have one of those fireworks that has a cone shape on it. All right. Everybody happy with this? So again, I'll give you the formulas, but you need to know what the letters mean and how to use the formulas. Seems like a fair trade? Probably. All right, so let's look at some examples. 3 tennis balls are packed into a cylindrical container, just touching the sides, top and bottom of the container, meaning they're wedged in like as tightly as they can go. The diameter of the tennis ball is 6.7 centimeters. Write down the internal height of the container, the diameter of the container, calculate the volume of the container, and then we want the curved surface is made of plastic and the tops are made of metal. So we want the area of the plastic and then the area of the metal. So let's think about this. What is the internal height of this container going to be? How many tennis balls high is it? And how high is a tennis ball? 6.7, so it's just going to be 3 times 6.7. Everybody happy with that? And what's the diameter of the container? It's the same as the tennis ball, right? If the tennis ball fits snugly in there, then they have to have the same diameter. Everybody happy there? Okay? So if I want the volume of the container, boom. Where's the 3.35 coming from? It's the half of the diameter, right? Everybody's good with that? So that's pretty easy. No big deal there. Cool? Okay. It's next we want the area of the plastic used, so that's the sides of the container. So I'll use the lateral surface area formula for a cylinder. That's the no base part. So that's just 2 pi RH. Everybody happy there? And the last asked for the amount of metal, which were the top and bottom. So that's the 2b part. The bases were circles, so 2 pi r squared. And there we go. This is even easier, I think, than the previous section, right? You're just like plugging stuff into formulas. I told you this section was, or this chapter was like a 4. Angela? Of course. Okay, everybody good? Next example. The base of a prism is a regular hexagon with sides of 3.5 centimeters, and the length of the prism is 19 centimeters. We want to calculate the volume of the prism, and then the surface area. This says regular hexagon. What does hexagon mean? 6 sides. What does regular mean? All the side lengths and angle measures are equal, right? Okay, so here's like our picture of what our pencil case is going to look like. So the volume for a prism is area of the base times height. Everybody good with that? How am I going to calculate the area for that regular hexagon there? Well, I'm going to take that regular hexagon and divide it up into 6 triangles. And I'm going to calculate the area for one of those triangles and multiply by 6. Everybody happy with that? So what kind of triangles are each one of these 6 triangles here? They are isosceles triangles. Very good. Even better, in fact, they are equilateral triangles. How did I know that this angle here is going to be 60 degrees? Excellent. So the area for a circle, or the amount of degrees in a circle, one full rotation is 360 degrees. I divvied that up evenly 6 ways. 360 divided by 6 is 60. And if this is 60, and these two angles have to be the same because it's an isosceles triangle, they both have to be 60 also because they have to add up to give 180, right? So that's really nice. So all these sides are 3.5. So I'm going to calculate the area for this triangle now. What formula am I going to use to do that? I'm not going to use area equals 1/2 base times height, because this is not a triangle that I know the height for. What am I going to use instead? Area equals 1/2 AB sine C. Remember that other area formula for a triangle we talked about at the very beginning of the semester? That's what I'm going to use here, because I know all this information. It makes it really easy. Everybody's happy with that? So the area for my triangle is 5.3-ish. So the area for my hexagon is 6 times that. And the volume for my prism is then 19 times that, which gives me the 604 and change. Are we okay with that idea? Again, that one was a little trickier because we had to find the area of that hexagon, which was maybe not trivial, right? We had to be kind of clever about how we did that. But any regular polygon, we could kind of do in that same fashion. Okay? So it's not too bad. It says the prism is going to be made out of this flexible plastic and sold as a pencil case. So how much surface area, which is going to be the same as the area of the material, do we have here? So I have how many of these rectangles? 6 of those, and then 2 of these hexagons. We already know the area for the hexagon because we used it in the previous part. And we know the area for the rectangle, just base times height. So the surface area is 2 times the area of the hexagon plus 6 times the area of the rectangle, give me 462 and change. Everybody happy with that idea? Again, not too bad, right? And again, you'll get all the formulas on the test or whatever, so you don't have to memorize all these area and volume formulas. Another example. Here we're going to make a lampshade from a cone of glass, and it's got a glass hemisphere as the base. We know the slant height of the cone is 29 centimeters, and the diameter of the hemisphere is 11 centimeters. So first we want the surface area of the lampshade. Question, does this lampshade have a bottom to it? No, how would you get a light bulb in there if it had a bottom to it, right? Okay, so it's just going to be the outside. We're not going to have the area of the circle here included. So with this cone, or I'm sorry, with the hemisphere here at the bottom, are we including the top of this hemisphere? No, right? The lampshade's going to sit on top of that. No top to that hemisphere. Everybody agree with that? So here's my surface area for the cone, not including a bottom. Here's the surface area for my hemisphere, not including a top. And so I just crunch some numbers then. Where's the 5.5 coming from? Yeah, the radius, which would be half of 11. So that's that. Pretty easy, right? The only tricky part is you had to realize that you didn't want to include like the top of the hemisphere or the bottom of the cone. Now, if I want the volume of the lampshade, How would I do that? Just going to take the volume of the cone and the volume of the hemisphere, add them together. Everybody's okay with that idea? So for the cone, its volume, I need to figure out the height. So I took this calculation triangle and I'm going to calculate the height. That's all that I need though, everything else I have. So if I plug in the numbers for the cone and the hemisphere, and then add them up, I get about 1250 and change. Everybody's okay here? Just FYI, on these problems, I'm going to be picky about the units. So make sure that your volumes are in units cubed and your areas are in units squared. Please try to do a good job with that because I will be picky about it on the test also. It's not a big deal, but like one more thing to remember, I thought I better point out to you and let you know that I'll be picky about it. That's it.